Dr. Laila Izyan Azhar, a presentation on modeling and simulation of quasi-static indentations and impact resistance of Arenga Pinnata nanosilica epoxy composites. Are you ready? Okay, let's start, please.
Assalamualaikum and a very good evening to the Honorable Chairman and also to all the participants. I'm going to present a study and modeling and simulation of quasi-static indentation of Arenga Pinnata nanosilica epoxy composites. And this study is also an extension from our team study. So we are going to still use, I saw Prof. Kai smiling there. We are still going to use the same materials for this experiment, for these simulations, okay? So this will be my presentation outline. I'm going to have a little bit of introduction, objectives, methodology, results and discussion, and also a conclusions. So as we all know, the natural fiber has many advantages. It has a natural availability, low cost due to abundance of resources, environmentally friendly, less harm to human body, and it has a good mechanical properties. Okay, so for the moving on to the composite material. Composite material is the material made from two or more constituent materials that combine or react from different physical properties. So the characteristic for composite material is strong, but it is usually to make a component is strong and stiff, often with a low density. Okay, therefore now for this study, we are going to do the quasi-static analysis, but it is not experimental analysis, it is a simulation analysis using ANSYS, where the quasi-static is an indentation test where the load was applied to the specimen at a constant rate of low velocity. The force is applied continuously until the final failure of the specimen. As you can see in the figure, we have a flat square of a specimen of Arenga Pinnata FRP composite panel that was subjected to a concentrated load in the middle by an indenter into the specimen surface. So this will be the objectives of the study. The objectives are to evaluate the quasi-static response to the effect of different volume fraction of Arenga Pinnata, which are 5 volume percent, 10 volume percent, 20%, and 25%. Then we are going to evaluate the quasi-static response to the effect of the presence of nanosilica content to the 20% volume content of Arenga Pinnata fiber reinforced polymer composites. So these are the general ANSYS simulation steps. The first phase will be the preprocessor. We are going to create the element, and then we are going to insert the material properties and the failure criteria of the material to the element. And then we are going to do the sectioning. At the sectioning phase, we have to add the thickness, we have to add the layer of the specimen. Then we are going to do the meshing. Then we proceed to define boundary condition, and also we are going to define the load to the element. Then the last one will be the solution of the simulations. Okay, moving on to the interface of the ANSYS simulation step. What you can see in figure A, it is the element that has been created in the software. Then in figure B, it is where the material properties and the failure criteria is inserted. These are the material properties that will be applied to the element that we have created previously. Then in section C, and then in figure C, it is a sectioning part where we will add the thickness layer by layer, and also we can apply the fiber ply orientation. In figure D, you can see the meshing step, where this is the most critical part, where we are going to decide how accurate our simulation results will be. We know that the smaller size of our meshing, it will give us more accurate results. However, the smaller meshing size, it consumes more time for the simulation to complete. Okay, then we are going to define the boundary condition. As you can see in figure D, the boundary condition is applied at all end line of the specimen. It shows that at those lines, the element will be fixed. Then we are going to apply a fixed concentrated load at the middle of the element, as it is a quasi-static analysis. Okay, we are going to repeat these steps for all our specimens. These are the specific dimension and also the specific fiber ply orientation that we use for this analysis. These are the input data of material properties that we used to insert in our step, ANSYS simulation step. These are the material properties that we need to have before we begin our simulation steps. So for this one, these will be the results obtained from the simulation. It is a displacement contour where you can see the red dot in the middle has the biggest displacement compared to the blue outer at the outer area, which it has a zero displacement. You can see in the figure. So for all our specimen, we have the same trend of the displacement contour, but it gives us different value. You can see the value is provided below at the below side of the analysis. Okay, these are the quasi-static response for a different volume fraction of Arenga Pinnata. So from these simulations, we collected all the data and we recorded in a table. And from the table, we convert it into a graph so that it can be clearly seen the differences between each specimen. So we can see the yellow line, which is we have 25 volume fraction of Arenga Pinnata has the highest indentation force compared to 10%, 15%, and also to the 20% volume fraction of Arenga Pinnata. Therefore, we choose this 25 volume percent of Arenga Pinnata to add the nanosilica. So we repeat the same simulation steps to the another specimen, to the specimen that we add on the nanosilica content for a different weight percentage. We have 5% of nanosilica content, 13% and also 25% weight percentage of nanosilica content. As you can see in the figure here, it still shows the same trend of displacement contour, but it gives us a different values of displacement. Then the data is recorded and we convert it into a graph. Then we can see that the blue line has the highest indentation force, which is consists of 5 weight percentage of nanosilica to the 25 volume percent of Arenga Pinnata FRP compared to higher nanosilica content to the AP-FRP. Then we have 20% of Arenga Pinnata, and now we have the highest results is 5% of nanosilica. Both of these results are then compared to the existing glass fiber reinforced polymer composites. So as we can see, we have a huge difference here. We have glass fiber reinforced polymer composite slightly constant in penetration depth. However, we have a huge difference at the our Arenga Pinnata specimen. However, we still need to validate our results with the experimental work because this is only as a prediction how the material behave under quasi-static response. So that's all from my presentation. Thank you very much.
Thank you, Dr. Azhar. And do we have any question for Dr. Azhar? No questions?